My name is David Bishop. It is October 1st. This is EET 238. This is lab number 2. And the purpose of this lab is to construct a series of logic gates to provide outputs. Those outputs are going to in turn be visually identified by these LEDs. This scenario or this lab consists of 4 different parts. I've got 3 of the parts wired up right now. I haven't done the 4th one just yet because I need to actually configure that, and one of the chips I need is actually already on the board, so I can't really use that just yet. So I figured it would be more pertinent to go ahead and knock these 3 out of the way so that we can see that they work out. So the first one, so this section right here is going to be for problem number 1, where we're going to have our 3 inputs, which are A, B, and C, and those, based on the setup, should ideally light this up if the inputs are high, and if it is not high, then this should not come on. The lighting in here is kind of dull, so you may or may not be able to see that. I'll try my best to actually make it visible, but I will be pointing at it so you can see that the bulb is actually lit up slightly. So with the first lab, we're taking our A, B, and C inputs on 0. They are all on 0. And then we're going to change these around. And as we change these, I've already recorded the readings for this one, but for this lab, for this video, I'm actually not recording them just for time constraints. But as you can see, we have our light lit up. And then we go over here. It's still lit up, but if we take some of these away, our light goes away. So, as you can see, I don't know what kind of gate this is supposed to be because it doesn't really specify, but we can tell that based on this configuration that the light lights up like it should. So that's lab number 1. Experiment number 2 is going to be here where we are making an AND gate out of NOR gates. So obviously with an AND gate you need all highs for a high output. This light's not as bright as the other one, so hopefully you can see this. But as of right now, here are my inputs for power. They are on ground right now, so obviously we don't have any power coming in. But if I change these, obviously I only have one high now. There's no light. But as soon as I have 2 highs, you can see that the light has actually lit up. So if I'm going to leave this screwdriver here, and you'll see that as soon as I take this away, that bulb changed. Go back, you can see it come back on just barely. Okay, so that was lab experiment number 2. Moving on to experiment number 3. For experiment number 3, the objective was to construct an XOR gate out of NAND gates. So here we have our setup 3. This chip's not really connected to anything right now because I was planning to use it but did not need to use it. So we have our LED here. For our inputs, since we only have 2, we have our inputs right here. Now, since this is an XOR gate, what should happen is you should only get a light lit up when you have an odd number of highs. So right now I have both of them on high. As you can see, I don't have any light. If I put them both on low, still don't have any light. But as soon as I take this, I get a light here. Go back, put this here, and my light has lit up. And then next, after I arrange experiment number 4, we will take care of that. Alright, and here we have experiment 4. And the idea was to construct an equivalent circuit to the XOR gate using NOR gates only. So we have our 4011s both right here. And after some finagling and realizing I had improper ground, I was able to get it to work. So as of right now, you can see here's where we're going to apply our power from. And it is now both on low. So with an XOR, obviously, you have to have an odd number of highs to actually get a high reading. So what we're going to do now is we're going to switch it up. See, the light came on. We're going to put it back. Going to put this on. Light came on. Going to put this on. And there you have it. And that completes experiment number 4 and this actual lab. So thank you.